All right, at the beginning of this topic, I made a promise to you. And the promise was that I would do something for you that I wish that my professors had done when I first started learning about electricity and started learning about all these concepts. And that is clarify the difference between all these electric things. So you have electric field, you have electric potential energy, you have electric potential, you have electric potential difference. How do these things, how are they alike and how are they different? And so I hope to do the best job that I can to clarify and explain that right now. So let's start with electric field. An electric field you can calculate using the formula E equals F over Q, right? Where F over Q is equal to the force that a charge feels in that electric field divided by this magnitude of the charge itself. All right. Another way you can calculate it is that it's the potential difference divided by the distance between the 2 points that you're calculating the potential difference between. All right. Now, conceptually, what is the electric field? Well, it's a way of answering the question, how is it that something over here can have an effect on something over here? And so the way it works is if you have a charged particle, let's say a positive particle, it creates a field through all of space. And if you take another charged particle and put it into that field, then the field acts on that particle. Not the particle, but the field itself acts on that other particle. And it's either going to want to move towards it or move away from it. All right? And so this is a really clever way of solving this problem of action at a distance. But before you think that electric field is just some kind of trick that physicists invented to explain this thing that they couldn't explain, the truth of the matter is it's very real and it's very measurable. Because if you take that particle and you start changing the field by shaking it, and you do it at just the right frequency, then you get light. You get electromagnetic radiation. And you can see it with your eyes or pick it up with, radio receivers. And so the electric field is something created by all charged particles in order to interact with other charged particles at a distance. All right, that covers that. Electric potential energy. What the heck is that? Well, as I said before, if you have a charged particle inside of an electric field, it either wants to move, with the electric field or against it. In other words, it wants to start moving. In other words, it wants to gain kinetic energy. And what do you need to gain kinetic energy? You need potential energy. So any charged particle sitting in an electric field has a certain amount of electric potential energy. All right, this desire to move one way or the other. So the amount of potential energy a particle has at a given location inside of a field, that's the definition. Its unit is joules. It's a scalar. And it's analogous to potential energy in mechanics, which we talked about earlier in another video. All right, so electric field is the field created by a charged particle. The electric potential energy is the potential energy that a charged particle feels inside that field. All right, I hope that's clear. What is electric potential? Well, electric potential is a way of simplifying the electric potential energy. It says that this is, the electric potential is how much potential energy you have per unit charge or per coulomb inside that field, right? How much potential energy each coulomb of charge actually experiences. Other important things to know about this electric potential is that its unit is volts, it's a scalar, and it's basically analogous to height in mechanics, right? Just like, charged particles want to roll from high potential to low potential, a ball will want to roll from a high height to a low height, okay? So this is another way of explaining why action happens at a distance, but instead of saying that there's a field interacting with someone, it's saying that there is a difference in potential and charge wants to move across that difference. Lastly, potential difference is just the difference between any two of these potentials, V2 minus V1. All right, so this is just saying, this is like your actual potential in your potential field. This is like you would calculate this for one point in space. But the difference between those potentials at two different points in space, that's the potential difference. That gives rise to driving charges from one place to another. That is the motive force inside of a battery that pushes electrons from one side of a circuit to the other. Its unit is still V. It is also a scalar, and it is analogous to the change in height in mechanics. All right. I hope that clarifies these different concepts a little bit better. And continue to ask yourself questions about it. Try to see the relationships between them. And the more you understand what the role of each of these is in the world of electricity, kind of the more simple the smaller the whole world gets. And when science feels small, then it feels a little bit more manageable.